differences compared between these two. Is all right? Okay, the differences on the neighbor relationship it be formed between OSPF and ISIS. And next is on the database synchronization characteristic. So what are the differences between these two on the OSPF and ISIS? So under similarities, OSPF and ISIS need to form a unified LSDB. Yep. So it means that whichever in the area, they must get a identical database. That's what I showed you yesterday when you're doing the lab. So you found that everything will be identical. If everything is identical, the same, that OSPF in the areas, they must having the same database. Okay, that is what it means. ISI is the same. The areas, you must get the same database. Okay, unified LSDB. So the differences over here is the area various type of the OSPF LSA, but few type in the LSP. Okay, so LSA, link state advertisement. LSP, link state PDU. PDU always we're going to put this as a layer 2. LSA is always as a layer 3. So do you still remember how many type of LSA that we have? We have a LSA. What type of LSA we have? We have routers. We have network. Okay, what else? We have net summary. We also have ASPR summary. We also have a AS externals. We also learn as a N SSA LSA. So these are the 6 LSA. Definitely, we also have a LSA 9, 10, 11. That is on the opaque LSA. But that is a common LSA that we need to grab the ideas. LSA number 1, 2, 3, 4, 5, 6. Oh, sorry, 7. Okay. The first two, intra, inter, external. So remember on this, that is what I mentioned yesterday. And for the LSP, it be very simple. That's it. They only have level 1 LSP and level 2 LSP. They will not divide like how the OSPF LSA it look like. So it just have only 2 type on the LSP. Level 1 LSP, level 2 LSP. Okay. And the OSPF and the ISIS database synchronization process are different. How the OSPF and ISIS database synchronization are different. So in the OSPF, the process is always the same. Like first you go for DBD. Okay. DBD is on the XStart. Okay. And also exchange. Then followed by loading. Under the loading, you're going to send the LSR, LSU, and LSACK and go up to the full state. So this is on the synchronization. They need to request, update, and acknowledgement. So let me just write it down properly. Okay, OSPF. So under OSPF, that what we have from here is we are going to send the DBD to describe what information that I have. Then I will send the LSR, the request, LSU as an update, and LS acknowledgement. That is always the sequence that I send. But compare into the ISIS, they have different way. They have different way according to the point-to-point and broadcast. Okay, they have two way of sending this information. So one is on the point-to-point, the other one is on the broadcast. So under the point-to-point, at the first, this is the first packet, that's second packet, third, and fourth. Okay. In point-to-point, the first packet they send is CSMP. Okay. Then I will ask for the PSMP, LSP, PSMP. So this is a sequence. The first one, it will be very similar to the, let's say compare back to the OSPF. This is a DBD. Okay, this is a LSR. This is a LSU. And this is a LS ACK. So that synchronization process is the same for the point-to-point. But when you go up to the broadcast, the first packet they send LSP to DIS. Second, DIS is sending CSMP to everybody's. Whichever that requests PSMP, we send to DIS and the rest. And the rest, DIS and the rest, will send the LSP. Okay, send the LSP to you, and you will send back the PSMP. So there is slight difference compared into the broadcast. Because of the DIS, they behave differently compared to the DR. Okay, so that's why the method of the synchronization of database are slightly different on the ISIS. Okay, especially into the broadcast environment. Okay, so that is on the differences. But for the point-to-point, yes, they are the same. So DBD is on the CSMP. CSMP is stand for Complete Sequence Number PDU. Okay, PSMP stand for Partial Sequence Number PDU. Okay, it's a partial sequence numbers PDU. So it means that it's just a partial. This is what I want. Request from you, and you send me the PSMP to acknowledge. So they have acknowledged as well as the request functionalities. And the last one, the lifetime of the OSPF LSA is increased during the transmission, and the lifetime of ISIS is LSP are decreased during the transmission. It means that from OSPF LSA, it starts from 0 and keep on accumulated, okay, to 1,000 to keep on increasing. But for the ISIS, it's from the maximum like 3,600, then they go to up to 0. Okay, this is going up, one is going down. That is on the lifetime, they are countdowning. One is increasing and one is decreasing. So that is the differences on the database synchronization of the OSPF and ISIS. Is that okay? All right. So that is on the database synchronization comparison between OSPF and ISIS. And the last one we look into this is on the other characteristic. Under other characteristic, OSPF and ISIS use the SPF calculation route. So on the SPF calculation, it means that they're using the ISPF, PRC, incremental shortest path first calculation, and partial route calculation. These are the two steps that I'm using to doing the calculation of the route. And both of them can prevent loop and support fast conversion and large scale of network. That is all agree. So when we have a link state algorithm, it's always suitable for the large scale, and also it's meant for fast conversion, because this is how they provide the fast conversion by the incremental shortest path first, and also a partial route calculation. Okay, that is what they can be supported. And next is on the differences. The differences between OSPF ISIS under the other characteristic. The OSPF cost type is simple. The ISIS cost type is complex. The OSPF support on-demand dial-up network, but ISIS does not. First, the cost type. The cost type in OSPF has only one cost type, no any other differences cost type. Okay, so it can be any numbers that you define from 1 to 16,000 or 65,000 of the cost that you define. But in ISIS, it's a bit complex. In ISIS, they are divided to narrow, wide, narrow, compatibles, and wide compatibles. Okay, so it means that they're going to have a different cost that I can define. For narrow, it's only from 1 to 63. For wide, it will be 1 to 16,000. That can be up to this. So the cost that can be assigned, it will be different. Okay, but in the normal situation for the ISIS, we always define as a wide. Okay, a wide cost style. Instead of using the narrow, we're using a wide cost style. Okay, because then in this case, there can be support matters. And because of in ISIS, is everything is more into the TLV, the type length value to do the extension. So in this case, we need to have a proper cost down method for us to define which one can be carrying more information. So don't care anything. Whichever when you go into the lab, when they have ISIS configuration, always change your cost type to become wide. Because wide, they can support a wider version, a wider function of the TLV. They can carry more information compared to the narrow. Narrow is a default, but we are better to change to the wide cost style. That later part on the next topic, I will cover more in detail on the ISIS cost style. Okay. And OSPF support on-demand dial-up. That's what I mentioned yesterday. This is inside the option flag. Okay, option flag. There are one DC bit. This DC bit is on demand. So it means that you only send packet when you need to use it. Let's say if not sending any packet going out, the connection is still up. Okay, but they will not send hello to maintain. All right. But ISIS, they does not support on the on-demand link. Okay, on-demand dial-up link. So that will be the differences. Okay, so far right now, up to this point, can you get a clearer pictures that comparison between OSPF and ISIS? Okay, that's good. Next, we check on the fault diagnosis. Okay, the fault diagnosis. So after the OSPF is enabled across the network, but R1 and R2 cannot ping to each other. How do you analyze and rectifying the fault? So what are the way you can rectify what fault that it caused this R1 and R2 cannot be pinged? So always we're going to classify to become two. First, we classify under the control and data. But most of the times, the things happen under the control. Okay, under the control. Or the data seldom, but if possible as well, if let's say you have any filtering been done on your interface, then under the data plane, you might affect it as well. So that will be the first, you need to identify these two category. And next, we look into one by one. All right, so under the control plane, if the neighbor relationship is down, when you find that your neighbor is down, what normally it means for? When the neighbor is down, it means that no, there's no peer at all. So check whether the physical interface work normally. So you're going to check more to the physical layers. And also the 5 factors, the subnet mask, authentication, area ID, configuration are consistent. Check whether the corresponding interface information is advertised by OSPF. Okay, need to check all these things. Make sure that they're able to form the neighbors. It's not stay up to the down state. So this is under the first. When the status is on the down. So remember how many states that we have in OSPF? We have a down state, init, two-way, exstart, exchange, loading, and full. So in total, we have a 7 state. Okay, 7 state. Let's say they will stop on the down state. Actually, it's not formed at all. The hello packet is not being sent at all. So in this case, you need to check if either your physical interface is working fine or not. And do you advertise any network into the OSPF? You enable OSPF, but you're not advertising, or you advertise wrongly, that you will not make it work as well. You will not make it work. So you need to make sure that whichever network you advertise is in the correct interface. Okay? So that is what you're going to check. Let's say the neighbor relationship is in the init state. Init state, they will not stuck under init state forever. No. Either down state or two-way state. They will not keep inside the init state. When init state happen, what it means over here is you need to check the local interface and the peer device are faulty. Okay, they have some fault happen on the interface itself or on the device itself. They have an issue. Otherwise, they will not start on the init state. When a two-way state, it's possible when they are having the priority of 0. When priority of 0, it means that they will form the DR others. When a DR others, you will start under a two-way state. Okay, under two-way state. Okay, and if the neighbor relationship is on the exstart, then you need to check the MTU. Either MTU is consistent or not. But the most easy way to know that what happened into your control plane, you can always do this command. Is called display OSPF error. When you display OSPF error, they will show you all the state and what type of error it can happen under the state. So they will have a counters to say that, oh, right now you have a bad authentication. Your authentication is failed. Your mismatch of the authentication type, your area mismatch, your network mismatch, everything will be shown inside this command. So let's say when you want to check under the control plane, you can check this using the display OSPF error. So exstart, check on the MTU. Okay, by default in Huawei, OSPF does not check the MTU in the D packet. They're not checked by default. Let's say you want them to check, you need to do the OSPF, MTU, and neighbors to make sure that they understand. Right now, we are comparing with the MTU and neighbors between the peers, between the neighbors. Is that okay? That is the exstart. For the exchange and loading, they will not start there as well. When they start there, you have to check whether they have a 40 of the peers or 40 of your local devices. Okay, that will be the troubleshooting method based on the layers that we have. Okay, if the neighbor relationship is under full state, but you can't ping to the destination, what you're going to check? First, check the network type. Okay, let's say one side is a point-to-point, the other side at broadcast. They can form full state, but they might not able to fully exchange the route information. Okay. Check whether the neighbor command parameters set are correct. Network command. Do you advertise a correct network statement or not. Okay, check back your information. Your wildcard they define, you need to be make sure you propagate correctly. So under the network, okay. So under the network from here, you need to advertise like this: 10, 0, 0, 0. You have a 0.0.0255. Okay. In this case, it means that you are advertising the /24. So in this case, you need to know what you're advertising, what address inside here I need to be advertising. So the network statement, you need to make sure your parameters is correct, and this is a wildcard. It's a reverse subnet mask. Okay, and next, check whether the external route to be imported are filtered based on the route policy. Is it filtered already? When the route is imported, does it do it properly? Do you have anything is not been imported, or there's some it be filtered by the filter policy already? Check whether type 5, type 7 to be advertised are filtered based on the filter policy export. Import is on the layer LSA type 3 or your internal route they had really filtered. You're not calculate based on this route. Okay, that is what we mentioned yesterday. You still remember? For export, it's meant for ASPR only. To filter LSA. Import, it can be on the ABR. You filter LSA. If let's say it's on the IR, you filter route. Okay, they filter different things. Let's say you are on the IR, then you filter route. You are on the ABR, you filter the LSA. And check whether the inter-area LSA filtering is configured on the process. They can be done on the process, also can be done on the interface. And check whether device is disabled from advertising summary type 3, type 5, type 7 into the OSPF process. If let's say they define as a stop, totally stop, and so on, and SSA. So in this case, they will not advertising this out from your area. Check whether the interface are configured the filter LSA. So they can be interface view or also can be under the process to perform the LSA filtering. And last, check whether a route that has a longer mask bit or higher protocol priority and different outbound interface from the OSPF route is generated by another protocol. Maybe let's say without OSPF, you have another one is using ISIS, and you change the preference already to make it more prefer. You have a preference of 5. In this case, I prefer OSPF ISIS than the OSPF. Okay, so that will be on the data control plane. Control plane when they're troubleshooting. So the next one they compare over here is on the data plane. Check whether the traffic filtering is configured on the interconnected interface, the policy-based routing you define, and also check whether the ping packet are cut by the intermediate firewall. Do we have any firewall intermediates to block this information? That is on the data plane. Data plane is seldom we're going to face on this. Let's say you have no any filtering in between. By right, you should be able to pass through. So far, okay? For the troubleshooting procedures on the OSPF v2, no issue, no questions. Next, we're going to start on the OSPF v3. So OSPF v3 and OSPF v2 is two different things. So OSPF v3 is only handling on the IPv6, and OSPF v2 is only handling on the IPv4 traffic only. So that will be have a huge differences. Okay, and under OSPF v3, they are carrying also using a different type of the LSA. Later in detail, we're going to cover one by one. You can see that later part, we also need to compare the difference between the OSPF v2 and v3. What are the differences? And how we configure OSPF v3 and on the suggestion OSPF exam preparation. So under the OSPF v3 introductions, okay, OSPF v3 have a similar working mechanism. Under working mechanism, they are the same between OSPF v2 and v3. But to support IPv6 address format, we have to build a new standard of the OSPF v3 to support IPv6, okay, to make some changes to the OSPF v2 to able to support on the IPv6. But one thing that's not been modified, okay, is the port 89 and the 32-bit unassigned integer as a router ID is still fall back to 32-bit. The port number are still remain as 89 and the router ID is still remain as a 32-bit. OSPF v3 is an enhanced version of OSPF v2, but is independent of OSPF v2. Okay, so they are not compatible. Okay, they is independent. So it means that running OSPF v3, you cannot talk to IPv4. OSPF v3 is only talk to IPv6 only. Okay, that's why it called as they are independent. There is enhanced version, but there is independent. They are isolated. So OSPF v3 does not support IPv4. OSPF v2 does not support IPv6. That is what it means. One is on the v4 and the other one is on the IPv6. So under the impact of the IPv6 on the OSPF v3, what is the impact? What are the changes that compare on the OSPF v3? The change in the v6 addresses from 32-bit, they go up to 128-bit. So definitely in this case, the length of the LSA will be increasing from 32 you up to 128-bit. And link locker address are added. Link locker address are used to send packet on link, excluding the VLink. So in this case, that we need to include the link locals and your unicast addresses. Yeah, global unicast addresses or the local unique local addresses. So this is all need to be involved. When I'm going to send my information to the link, I would send using the link lockers, except the VLink, virtual link. Virtual link, I have to use the unicast address. Because virtual link is from one to the others. My link lockers is only within my link only, cannot be up to a next link. Okay, so it means that let's say I have a router A, router B, router C. Okay, so I built a VLink from here. So this is the link. This is the link. Okay, link lockers is only in between. So link lockers is only communicate with the link, within the link. When you have a virtual link, okay, between the virtual link, I have to use a unicast address. Unicast address. The global unicast address to communicate between the A and C. So between the link, yes, I can using link lockers addresses. Because as we know that for IPv6 addresses, we can configure multiple v6 address under a single interface. We have link lockers and global unicast at the same time. It's possible. Okay, it's possible. All right, this is what the changes. You need to add on the link locker addresses. And for the changes in IPv6, multiple global unicast IPv6 address can be configured on an interface. That's what I mentioned earlier on. So you have a GUA, multiple GUA under a same interface. And the communication is based on link instead of subnet. It means that in this case, in the IPv6, let's say over here I have 2001 colon 13 colon 1 64, and from here I have 2001 colon 23 colon 1 64. These two address, it can be ping. You can be managed to talk to each other. Okay, you can talk to each other even they are under different subnet, different prefix. They still can communicate as long as the link lockers are there. Okay, they're using link lockers as the next hop for them to perform the communication. Okay, because they're based on the link to communicate, they do not based on the subnet. For IPv4, they're based on subnet. They must be within the same subnet for them to communicate. You still remember that in the OSPF, in the IPv6, they're going to exchange the neighbors. They're going to know who is the neighbors, the neighbor information, what information that I have, what is your MAC address, what is your link locker address, and so on. I will have exchange by using my NDP protocols, my NA and NS to discover who you are, and I have a neighbor tables, okay, a neighbor tables. So in this case, that's why I do not compare with the subnet. I'm going to base on the link for me to communicate with you. It can be just within the same link. Even you have different subnet, I still can communicate with you. That is a benefit by using the IPv6. But the best definitely it be within the same network. Okay, within the same subnet. That would be the best. And extension header for the IPv6 authentication. Okay, in this case, for the extension header are used for authenticating and encrypting of the packet. So under OSPF v3, they are removing the authentication. They have no authentication under OSPF v3. Authentication, they do it on the IPv6 header itself, okay, to provide the authentication. So later we're going to check what are the differences and what are the differences headers compare back to the OSPF v2. Okay, so far up to this point, any question? The impact of the IPv6 on the OSPF v3. So this is some of the impact, but it's not the huge impact. You just have to understand it. You need just need to understand and deal with it. That's okay. Okay. And the similarities between OSPF v3 and OSPF v2, network and interface type, they still remain. For network type, okay, interface type as well. Okay, and interface and the neighbor state machine is still going through the 7 state: down, init, two-way, extra, exchange, loading, and full. Okay, so for the MBMA, they have slightly difference. So they add on a attempt state under the MBMA. This one differences. There's not the differences between version 2 version 3, but for the point-to-point broadcast and also the point-to-multipoint, they're having 7 state. But for MBMA, they have 8 state. Same for OSPF v2 and OSPF v3. They are the same, but just that MBMA go for 8 state, and point-to-point broadcast, point-to-multipoint, they go for the 7 state, okay, or the negotiation. Database, yes, the same. Flooding mechanism are the same, and the packet type, hello, DD, LSR, LSU, LSAC, is still be the same as well. And the route calculation, ISPF and PRC, that's also the same. So all this information are the similar between the OSPF v2 and OSPF v3. Okay. So far, right? All right, let's say it's okay, then we just continue for the next one. The next one, you go and check on the differences between OSPF v2 and OSPF v3. Just now we look into the similarities. Right now we look into the differences between the OSPF v2 and OSPF v3. So what are the huge difference and where's the main difference between these two? So for the differences here between the OSPF v3 and OSPF v2 that we have over here, is on the link-based operation. They're based on link-based instead of using the interface-based. Okay, what over here I from define from here. So link-based operation. So as in just now I mentioned, in the OSPF v2 are based on network. Okay, based on network. They must based on the subnet, the same subnet to perform the communication. But in OSPF v3, they're based on only the link layers. Okay, on the link layers. All right. And link locker addresses, that is one extra they added in, link locker addresses. Link locker addresses always be their next hop when they're going out for other areas or other network. They're using the next hop as a link locker addresses. But in OSPF v2, they do not have such information. They will just always point to the next routers as a next hop. And they support multi-instant multiplexings. So it means that you can be running multiple instances together to provide a multi-topology. And the support authentication are different. Authentication, this is under the IPv6 headers for OSPF v3. The stub areas also slightly different. Packet for the packet format, there are different as well. Contain in the option field and the LSA type and the contain. They have a lot of differences on this. Generally are the same, but when look into in depth, then you will see the differences. And now we look into one by one. Okay, one by one of the differences between the OSPF v3 and OSPF v2. What are the main differences between all of those? Okay, first we look into the link-based operation. For link-based operation, you can see that from here, that is on the /32/32/32. So actually it's on the different segment. This is 16, this is 16, 32, 32, 32. So actually they belong to 3 different segments, but they still can communicate within that, even though they are not within the same segment. Okay, but as long as they are under the same link, yes, I will able to communicate. Okay, OSPF, they must be within the same network segment. 2 routers must reside on the same network segment if they want to establish the neighbor relationship. Okay, but OSPF v3 is implemented based on the link. A link can divide it into multiple subnet. 2 nodes can communicate with each other if they are on the same link. This is what their concern. Regardless of whether they reside on the same network, same subnet, it doesn't matter. But the more important over here is based on the link. The link, they are the same. Okay. So far, questions? No. So always remember the link. What it means the link? When they are attached together as the same layer 2, we consider it as a link. Okay. Prefix do not need to be matched. Okay. As long as when they are in the same link, these 3 devices should able to communicate to each other. And next is on the link local addresses. Link local addresses. OSPF v3 router use a link local address as a source address for the sending the packet. Okay, so they send a packet, they're using the link local address. So all the other routers connected to the link and use the link local address as the next hop to forwarding the packet as well. Okay, within the link, within the link. And on a virtual link, the global address or link local address of the site must be used as the source address of the OSPF v3 packet. But normally for this, we're using as a global addresses. Okay? Global addresses. Link local address is valid only on the local link and cannot be flagged only on the local link. Therefore, a link local address can be carried only the link LSA. So actually, this one is only within the same link, only between you and me. Within the same link, then they will going to exchange the link LSA. Okay, this is a link LSA. So this is one of the extra LSA they added in that is not inside the OSPF v2. Because OSPF v2 they have no link layers. They don't have any link lockers. Only OSPF v3 they have link lockers for them to carry this information. Okay, for this on the link local addresses. So far, any question? All right. So for the next one is on the multiplex of the multiple instance. So it means that for a single interface, it can running multiple instance running different OSPF sections can be done it together. So OSPF allow multiple instance to run on the same link, multiplex link, and reduce the cost. So you see that router C and router D are not belong to the same instance. I have an instance between A, B, C, and A, B, D. So you're going to have two instances of the OSPF. Okay, but for all these four routers are connecting to the same broadcast network. But the sharing can be established neighbor relationship. Instance 1 can create the Ethernet 1 on the router A, and Ethernet 1 of the router B, C is one instance. And instance 2 for A, B, D as another instance. So this implement by adding the instance ID. They're going to add on the instance ID to differentiate that they are belong to two instances. If the instant ID configured on an interface is a difference from the instant ID they receive, then this they will discard. They do not establish any neighbor relationship. So in this case, you can define this as instant number 1, instant number 2, instant number 1, instant number 2, instant number 1, instant number 2. So I only accept instant number 2 information come to me. I only form the instant number 2 relationship with the A and B, and C you only form with A and B as well. Okay, that is how you can be specified multiplexing of the multiple instance. Okay, let's say you're going to have a two instances that C talk to AB, D talk to AB, but C and D they will not exchange the route information, and this is what you can provide by divided them into the multi-instance. Okay, to two different instances. That is possible on the OSPF v3, but not OSPF v2. Okay, it's not possible because OSPF v2 they do not have the instant ID we can assign to, and we cannot use to identify whether which instance you come from. We can't do that into the OSPF v2. And the next one is on the authentication. Authentication changes on the OSPF v3 packet that do not contain the authentication type and also authentication field. They do not include this anymore inside the OSPF v3. OSPF v3 generally depend on the v6 extension authentication header to implement the verification. Okay, so OSPF v3 use the standard IPv6 checksum to check the changes of your authentication. Okay, so they already remove this. They do not have authentication inside your OSPF v3 packet anymore. They do not have this information available for you to set the authentication direct on the OSPF layers. You have to do it on the IPv6 layers, layer 3, okay, to set what is your password. Okay. And for the start area, for the OSPF v3 can flag unknown LSA. Okay. To prevent a large number of unknown LSA from being flooded to the stub areas, OSPF v3 allowed an unknown LSA to be flooded to a stub area only if the LSA can be flooded within the areas or a link, and the U bit and 1 bit has been set. So that is the bit they're going to define. Later, I'm going to mention what is a U bit. It's not set to 1 that can be allowed to flood the unknown LSA. Because of inside the IPv6, they do not have any broadcast method anymore. They do not have any broadcast address. Whichever they send as using a multicast addresses. So in this case, they will have a lot of unknown LSA that might send or into the stub. How they're going to allow whether this can be allowed or not allowed, they need to check certain conditions. They need to check whether they check this LSA can be flooded within the area or in the link or not. And the U bit. The U bit is called the unknown LSA. They do that allow them to forward into the LSA. So in this case, it can control. Those unknown LSA they accept, do they want to flood or do they want to just prevent it to accept? Okay, that is on the unknown LSA. But later when we go into the LSA method, we can go in more in depth into this on the about the unknown LSA. Okay, so that is on the stub areas. They have something different compared to the stub that we learned on the IPv4. So for the packet changes, first we look into the headers, the header field of the OSPF v3. Okay, so this is on the OSPF v2, OSPF v3. Okay, they have two. Under OSPF v2, we have version, type, packet length, router ID, area ID, checksum, authentication type, authentication field. Okay, but when you go to OSPF v3, we have only left version, type, packet length, router ID, area ID, checksum, and all these three has been changed to the instant ID and reserve. For this instant ID is for what we just mentioned about, is for the multiplexing of the instances. You can provide multi-instant of the neighbor forming based on the instant IDs. So that field, either have a version 2 or 3. Okay, this is 2 and this version 3. And the type over here is depend on what type of packet you are carrying. They will have a 1 is DD, 1 is hello, 2 is DD, 3 is LSR, 4 is LSU, and 5 is LSX. So it's the same. For the type, hello, DD, LSR, LSU, LSX is the same. And the packet length on the OSPF v3 packet has only 2 bytes. Okay, in total, this is only 2 bytes. Okay, and for router IDs, it's still the same, 32-bit integers. 32-bit integers. Okay, but for this router ID, there's certain things you need to be aware. You still remember that in OSPF v2, how the OSPF router ID will be selected. So how many ways we can specify on the router IDs? Do you still remember on that, on the router IDs in OSPF v2? So OSPF v2 always we recommend that you configure router ID manually yourself. Let's say you not define router IDs, okay, I will select one router ID for you on behalf. I will select your highest loopback interface as a router IDs. Second, let's say you have no loopback configured, I select your highest active physical IP address be your router IDs. So this is the selection criteria on the OSPF v2. So at least, let's say you forget to configure, they still will going to select for you. But in OSPF v3, not on this story. There are no such stories that I'm going to perform auto discovery for you. No. In the OSPF v3, you have to do it manually yourself. Let's say you did not do it manually, okay, your OSPF cannot form. So that will be the tricky things. The router ID in the OSPF v3, you have to configure manually by yourself. You need to do it manually. Okay, that is the things they need to be aware. Area ID is the same. 32 bit. Okay, 32 bits. Yeah, the same as a 32 bits. Okay, the area there's no difference. Okay, area no difference. Checksum, no difference. The instant ID, there's the field is differentiated OSPF instant running on the same link. Instant ID are valid only for the local link. Okay, local link layers, and 0 as a reserve. So this is how they are reduced. The reduce on the OSPF v3. So in total from here, they're only up to 16 byte. Okay, 16 byte. Okay, because they deleted the authentication type, they deleted authentication. They remove all this non-necessary. All this can be done by the IPv6 headers already. Is that alright? For the header field description under the OSPF headers. Then first and next we look into the hello packet. The hello packets. So the top is the headers. The top over here is on the OSPF header. Based on the type, when the type is 1, it means that you're carrying this as a hello. This is a hello. Okay. For hello, it do not have a lot of huge difference. Just that from the network mask, they change to the interface IDs. Instead of the mask, they will change to the interface IDs from here. Okay, so interface ID, you tell you that that is where they receive from, where they come from on the information they receive is from these addresses. Okay, from these addresses. And for the hello interval, they reallocated over here. Hello interval, that interval, router priorities. I'll still remain. I have hello, route, the dead intervals, and also routers priorities. It still remain. Just that the option bit, they are different. Okay. OSPF v3 extend the option field to up to 24 bits. So this one is only 8 bits. Yeah. Last time it's only 8 bit, but for the OSPF v3, they make it to 24 bits. It means it's 3 byte. Okay. It will increase 2 more byte into the option field. And next we look into this. Designated router IDs, backup router IDs, that's all the same. Then neighbors. Who is your neighbors? That is on the hello bucket. On this hello information is all identical compared to the OSPF v2. The only differences over here for the hello bucket is the interface ID and the option field. They increase 2 more byte from 1 byte to become 3 byte. Okay, the rest are all the same. Okay, still the same based on the DR priorities. The priority is the highest, become the DR. So this is the DR priorities. So far, okay? So next is on the option field. From 8 bit to 24 bit, what are the differences from here? So from 8 bit to 24 bit, let's look into one-to-one. DC is the same. No, sorry, not the same. DC is DC here. It's an on-demand link. Okay, DC is just an on-demand link. So what else? There's the same. This MC is the same. This E is the same. This N also the same as an NSSA. The difference over here, they have a R and a V6. Okay, the R bit is just indicate whether a device is a router with the forwarding capabilities. If the R bit is set to 0, the router information of this device does not participate into the route calculation. If the current device is not expected to be forwarded packet that carrying does not local addresses, the R bit can be set to 0. Okay, let's say they were just carrying non-local addresses, the R bit can be 0. But when you are the router who forward this information, you should see this R bit is equal to 1 to sending. I'm the router who have a forwarding capabilities. Okay, and the V6 bit is just the V6 bit is set to 0. The router or the link does not participate into the IPv6 route calculation. Okay, when it's 0, means that for these devices or this connection is not take part of the route calculation. So when you're under IPv6, or normally this should be 1. But you can disable this function by set the V6 bit to become 0. The E bit is still the same on the external LSA type 5. This is still the same as on the multicast. Okay, and SSA. DC is for the on demand. Okay, they remove this empty. The multi topology they remove because inside the OSPF v3 they can easily provide the instances, the instant ID to provide the multiplex instant within the link. Okay. So this is on the LSA type 8. They do not support on this. OPEC, they do not support on this as well. There's no OPEC LSA. They have no DN on the IPv6 yet. Okay, it's not up to that yet. So that is on the capabilities they can support. They're actually using from 18-bit to 24-bit at the moment. So it means that they have a room for them to perform the extension in the futures from 0 to 18. They can carry other type of the flag in the futures from 0 to 18. Okay, this is on the option field that we're talking about. So at the same time over here, also let me just capture, I just forgot I need to capture the attendance. Let me capture attendance for this morning. Okay. All right, so I think that I'm going to just take a stop from here before I go for the LSA headers. We take a break of 15 minutes, then come back, we continue with the LSA headers. Is it okay?
Okay.
Okay, thank you.